Hi everyone, welcome back to my AP Calculus class. Today I'm going to explain shell method to find the volume by revolution. I explained two other methods to find the volume by revolution last time, which are disk method and Washer's method, right? But today I'm going to explain shell method. You have to understand first one. Just memorize the formula and use it, but you have to understand this. When the volume is revolved, okay, rotated about horizontal axis, we use x values and x functions and dx for washers and for disk method the last time we used, right? If the volume is rotated about vertical axis like y-axis, we use y values upper limit and a lower limit over the integration, and then all y functions and y dy, right? But shell method is opposite. If you're gonna find the volume rotated by about horizontal line, yeah, we have to use all y values and y function and dy. This is opposite, right? When you find the volume rotated about vertical axis like y-axis, we use all y functions and y values, but for the shell method opposite, use all x numbers, x values, x function, and dx. Okay, I'm gonna give you a basic concept, basic formula. It's very important. Okay, basic formula of using that shell method is always use that integral a to b r times h times dx over dy depends on rotated up vertical or horizontal. If there's vertical axis is dx, right? And then 2 pi in front. This is the formula to find it. I will use this formula to solve example 10, and then I solve just two problems very slowly because the shell method is kind of a little more difficult to understand. Start from example 10. Find the volume of the solid generated when the region bounded y equals x squared and x equals 2 and y equals 0 is rotated about line x equals 2. This vertical line is x equals 2. So it is a volume generated by rotation about vertical lines. It's all about x values and x functions and dx, opposite from the other method, right? So if rotated, just find the random y. This is y, and then that point is here, yeah? It's a random x here. And then if the rotated that point, okay, rotate this line, this radius, about x equals 2. They're gonna be like this, right? This gonna be shape gonna be fine there. Kind of cylinder shapes. Okay, by the formula, 2 pi times integral 2 x values. It is not about endpoint to endpoint. It's about what endpoint to center of the rotation. So is 0 to 2 is not 0 to 4, okay? 0 to 2. So 0 to 2 to x values. And then radius. Radius is this, r. In terms of x, I told you it's all about x value, x function dx, right? So this length is from 0 to center of rotation is 2. And then this is x, right? So actually the radius of rotation is 2 minus x. That's 2 minus x. It is r part. Okay? What about height of that cylinder, that shape? This is height. This is y value, right? Y value of y equals x squared function, but it's all about the x. So times y. Y means x squared times x squared and dx. Just calculate it. You can find the indefinite integration equation, then plug in top number and plug in bottom number of, or if the problem is calculated, section problem is calculated, it doesn't matter. If we find it, this solution says, oh, happens again. Always this happens, I don't know why. Let me quickly go back there. Because this iPad is very sensitive, I think. That's why. Sometimes it happens. Oh, over here. Okay, welcome back. The answer is what? Yep, 8 pi over 3. So you can use calculator, or you can find indefinite integration value plug in top number and bottom number. Don't forget you have to multiply 2 pi. It's not perfect, yes, so I can explain all more examples about shell method. Let's go to next example problem. What about this problem, example 12? I think it's a very good problem, okay? Because it's revolved about the x-axis. X-axis is horizontal, axis. That means all about y value. And a little different. The shape is not cylinder shape, right? The shape is kind of Washer's method shape. In that case, can use kind of difference, okay? I'm gonna explain first. All right, there is a y equals x squared and y equals 2x. And then find that volume obtained when the region, bounded region, okay, revolved about x-axis. Let me explain that. This function is y equals x squared, and then this straight line's equation is y equals 2x. Bounded region means this region, right? And rotate about x-axis. So that shape will be something like this, right? And then what about at random x? If it's rotated about x-axis, right? So by the formula, it's all about y. So integral 2 pi integral at first. What is y value from the one end point to center of rotation? 0 to 4. So it is not 0 to 2, it's 0 to 4. 0 to 4. You got it, right? And then radius. In kind of not Washer's method shapes, that means cross section is kind of donut shape, not disc, right? In that case, you use a shell that RHDX or RHD. In this case, RHDY, right? Because it is about rotated about horizontal x-axis. So R times H times dy. But think about R and H. When you decide R, in this case, there are two R's. Kind of bigger R, larger R, and small r, right? You always have to use small r. Small r is this length, right? That is y. And at the random x, the length is y. So y times. Oh, it is x squared, but you don't have to change to x squared because it's all about the y function. It's not x function, right? So y times height. Okay. When you find height in the shell method, okay, and then that shape is cross-section shape is donut shape, not disc method, like Washer's method. In that case, that height is kind of difference of two x values. This thickness of that shape is the reason, kind of. So that is x2 minus x1. X value of that y equals x squared function. Okay, this x is x2, this x is x1. The difference is thickness of that. That is a height, kind of. That is a height. So radius, smaller r radius times thickness. Okay, so y times y is radius r, right? And then times there's x2 minus x1. That part is very important, right? dy. But we need y function, not x function. x2 is x value of y equals x squared. So what is x equals? Square root y. Okay, so I'll change that. 0 to 4 y times root y. And what about x1 is this x, right? Oh, okay, that is what x of this function straight, right? Y equals 2x. So x equals what? Y over 2. Y over 2. Okay, so minus y over 2. So x2 minus x1, that thingness, x2 minus x1, I change x1 and x2 and x1 into y function. And then dy. And then you can use a calculator now. You can use a calculator to calculate this value. Maybe this is calculator section. Okay? I can explain one more problem. I planned 2 problems, but I'm going to do one more because I'm not sure how much you understand this. What about this? Y equals 3x minus x. This function is y equals 3x minus x squared. And that this function is y equals x. And then the boundary region, this is rotated about y-axis. Yeah, something like this, right? Y-axis. Something like this. Okay, I told you, it's vertical line, vertical axis, right? Rotate about the vertical, all about the x function now. So in 2 pi integral x value 0 to 2. And the radius, I told you smaller radius, right? There's smaller x. So that's x value, right? X times. You don't have to change it to y because it's all about the x now. Because it is rotated about vertical line, that's why. And then thickness, right? The thickness means this length, right? So this function y2, this is y2, this is y1. So y2 minus y1, that is kind of thickness of the shaded region. Okay, the thickness is perpendicular to radius of rotation. So that x represents radius of rotation, right? And then thickness means perpendicular x is about the radius. So change of y values, y2 minus y1. And then dx. Then change y1 and y2 in the x function. 0 to 2x times y2 is this. 3x minus x squared minus y1 is x, right? And dx. You can use calculator to find its value. Okay? That is the answer. All right. So I solved 3 shell method problems. Remember that. Remember what is the formula? The formula is in 2 pi times integral a to b radius of that rotation. There's sometimes you have only 1 radius, sometimes you have 2 radius, bigger circle's radius and smaller circle radius, right? That is small r, that is not large r. Smaller circle's radius times height. Sometimes you have the 1 height, but sometimes kind of Washer's method shapes, we have to find the thickness of that shaded region and dx, or sometimes dy depends on vertical axis or horizontal axis. What is their rotation axis? I hope you understand very well. Shell method is harder than the others. And if I have more chance to, when I solve that exercise problem, I believe that we have more chances to shell method. Okay, I'm done today. Thank you for watching my video. Then please click subscribe and like and turn on the notification. Have a good day. Bye bye.